Dear student, in today's lecture, we start article electric potential from chapter electrostatic. Now, what is electric potential? You already use this word electric potential many times. So, what is electric potential? So, electric potential is basically a work done to bring a unit positive charge from infinity to a point in electric field. This is the electric potential. For example, if I consider one charge, let's say plus q charge, and this charge plus q having an electric field in its surrounding area. This circle represents electric field of this charge. Now, within that electric field, if I consider this is the point A, and to that point, if you want to discuss what is electric potential at point A, so that time, if I consider infinity distance, from infinity distance, a unit positive charge, if you bring at point A, then some work is done. And that work done is nothing but electric potential. So work done to bring unit positive charge from infinity to point in electric field is the electric potential at this point. So infinity distance to point A, if you bring unit positive charge, work done in that case is called as electric potential. This electric potential is given by this formula, W by Q0. Unit. SI unit is joule per coulomb, or it is also called as volt. So dimension of work divided by dimension of charge. By solving this, we get the dimension for potential, L2 M1T minus 3 I raised to minus 1. So this is the dimension for electric potential. Now electric potential due to point charge. Electric potential due to point charge is given by formula 1 upon 4 pi epsilon 0 q by r. This potential is given by formula 1 upon 4 pi epsilon 0 q by r. If this charge is placed in free space or vacuum or in air, then this is the electric potential due to a point charge. After this, electric potential energy. Now, what is electric potential energy? So, electrostatic potential energy is the work done. It is work done against electrostatic force to achieve a certain configuration of charges. So you know that work done and energy, they are equivalent. So electrostatic potential energy is work done against the electrostatic force. Work done against the electrostatic force to achieve a certain configuration of charges. So basically remember work done is the potential energy. Consider, now we consider one charge, positive charge Q. It is fixed. Positive charge Q is fixed at some point in space. For bringing any other positive charge close to it, work is done, which is equal to the potential energy. So you remember. So if I consider the positive charge Q, which is in the space, and to bring any other charge close to it, close to this charge, some work is done, and that work done is called as potential energy. Now here a simple diagram you can see. If this is charge, okay, this is charge plus Q. And if we bring any other charge, for example, this positive charge plus Q0, closer to this charge, then some work is done. And that work done is nothing but the potential energy. Thus, we can write here the work done against electrostatic force is equal to increase in the potential energy. If you see, when we are bringing this charge in this direction, some work is done. Some work is done against the electrostatic force, F. So we written here work done against the electrostatic force is equal to increase in potential energy. So we get one formula here. So work done is force into displacement. If I consider that a charge is displaced from A to B, so displacement is dr. Electrostatic force is F. Okay? So we get increase in potential energy is equal to F into dr. This is the formula for increase in potential energy. So du is the increase in potential energy, dr displacement, and F is force exerted on the charge. I hope you understood this potential energy. Now after this, a next article is expression for electrostatic potential energy. Expression for electrostatic potential energy. Now we consider a charge. Again, you can see in a diagram, charge plus Q is placed at point O. Okay? Unit positive charge plus Q at A. Okay? And this point A is at a distance R1 from this charge Q. Now consider the electrostatic field due to a charge plus Q. So we are considering electric field due to this plus Q charge. And the origin is O, means this charge is placed at point O. Now let small charge plus Q0 be brought from A to B. So this charge is brought from A to B. So this we have to bring from A to B. So distances are R1 and R2 from O. R1 and R2 are the distances of A and B from a charge. Work must be done against the repulsive force. Pay attention, both are positive charges, so repulsive force. Okay? And work must be done against that repulsive force. So here pay attention, work done to move a charge Q0 through a small distance dr. So first we find out work done to move a charge with a small distance dr against the electrostatic force Fe. So this is the dr is the small distance. We find out work done for that. Then we find out total work done to displace it from a distance R1 to distance R2. So we get formula work done is equal to force into displacement. So force is the electrostatic force, okay, and this into displacement dr. Now work done appear as increase in potential energy, and this work done appear as increase in potential energy. So just we already discussed in the previous article. So work done appear as an increase in potential energy. Now same equation we are written like this. du is the increase in potential energy is equal to minus Fe into dr. So now I'm not written vector form here. So you can see here it is F bar and dr bar is written. But here I written directly minus sign. Minus sign indicates that this work is done against the restoring against the electrostatic force. So because of that minus sign is coming. Okay? Or you can say, so this Fe and dr, so they both having opposite directions. So this is the direction of electrostatic force and displacement is opposite to that. Okay? Negative sign shows that displacement dr against electrostatic force. For the displacement of charge from initial position A, for displacement from initial position A to the final position B, the change in potential energy, pay attention, for a displacement of charge from initial position A to B, change in potential energy can be obtained by integrating this. If we integrate this equation, then we get the change in potential energy, total change in potential energy. So integration within limit we have to do because we have to displace the charge from this R1 to R2 only, A to B. So we can write here. So change in potential energy is equal to integration of du within a limit R1 to R2 because we have to displace a charge plus Q charge, Q0 charge from point A to B, means from distance R1 to from distance R2, and both the distances are measured from the same point O. Now we substitute here du. So we get minus integration Fe dr. So this formula we get. The electrostatic force between two charges separated by distance r. Electrostatic force. And the electrostatic force we get by Coulomb's law. We get electrostatic force by using Coulomb's law. जो Coulomb's law हमने इससे पहले already learn किया था. So what is the electrostatic force? Electrostatic force is 1 upon 4 pi epsilon 0. First charge multiplied by second charge. Okay, first charge is capital Q. This charge is Q0, small q0. Divided by distance is r square. If the distance of separation between these two charges is r, then electrostatic force is given by this formula. Okay? So this is the electrostatic force. Now, after that, for a system of 2-point charge, for a system of 2-point charge, so increase in potential energy is equal to, I written this again. So this is the electrostatic force that we have to substitute. And after substitution, we get this formula. We get this formula. We substitute only here electrostatic force. Electrostatic force we substitute. Now we have to simplify this. Now this 1 upon 4 pi epsilon 0 is constant, Q into Q0 is constant, so integration 1 by r square dr. Okay? Then integration, this integration 1 by r square dr is minus 1 by r. This integration is minus 1 by r. And if a limit is there, r1 and r2, we have to put the limit now. Okay, so we are written here the integration. So this minus multiplied by minus is plus. ठीक है. Now we substitute the limit. Now instead of doing this minus into minus plus, otherwise we can do it minus multiplied by minus plus and we substitute the limit. ठीक है. So or we can write the another step here. Pay attention. 1 upon 4 pi epsilon 0 minus वाला. Then q into q0. ठीक है. Minus 1 by upper limit we have to substitute, which is R2. ठीक है. Then minus and this minus minus plus 1 upon R1. ठीक है. We get this. Then if you take a minus common from this, then minus minus plus. So 1 upon 4 pi epsilon 0. So q0 1 by R2 minus 1 by R. So this equation, you can see the same equation is written here. Okay, this is the basic mathematical steps that you already learn. या आपको मैथमेटिक्स में ऐसे स्टेप्स आपको लर्न करने हैं. दिस इज सिंपल इंटीग्रेशन. जो मैथ्स में इंटीग्रेशन आपको लर्न करना है, दैट टाइम यू फाइंड इट इज वेरी इजी. ठीक है. नाउ this is the increase in potential energy. This is increase in potential energy. The change in the potential energy or increase in the potential energy depends only on the end point and is independent of actual part taken by the charge. Pay attention. This is very important. Change in potential energy depends only on end points and is independent of the actual path taken by the charge. It is independent by actual path. Means how the charges are displaced from one point to another point. Based on that actual path, it is independent. So it depends on only the end points. So here you can see here R1 and R2 is mentioned. So point A and point B, these are the points. Okay. Now, I hope you understood this derivation. Now pay attention. So this work done to displace from point A to B is equal to this change in potential energy. So this work done is equal to the change in potential energy. And the change in potential energy formula is already known. So work done to displace a charge from A to B is given by this formula. Okay? It is convenient to choose infinity to be the point of zero. It is convenient to choose infinity to be the point of zero potential energy. Means at infinity we are considering zero potential energy. As the electrostatic force is zero at distance infinity. Why we are considering this is zero? Because distance is infinity. So the potential energy is zero. Electrostatic potential energy of system of two charges Q1 and Q2 separated by distance r can be obtained. Now let me consider here at infinity potential energy is zero. Now here we can write electrostatic potential energy which are separated by some distance r. Electrostatic potential energy between two charges separated by distance r can be obtained by. So means here r1 distance I substitute infinity and r2 is equal to r. It is the distance between two charges r. Okay? Then we get a formula, and this is the final formula for electrostatic potential energy. You remember this formula. Electrostatic potential energy is given by formula 1 upon 4 pi epsilon 0 Q1 Q2 divided by R. This is the potential energy formula. Now we write this formula for several cases. So different cases we have to consider for this formula. Now this unit of potential energy. So you know that energy having a unit joule. So obviously this electrostatic potential energy also measured in joule. So you remember one thing here, 1 joule means how much? 1 joule is the energy stored in moving a charge 1 coulomb through a potential difference 1 volt. 1 joule is the energy stored in a charge of 1 coulomb through a potential difference of 1 volt. Another convenient unit is electron volt. This electron volt unit is also unit of energy. Okay, we can represent this potential energy in electron volt, and which is the change in kinetic energy. What is the electron volt? Electron volt is the change in kinetic energy of electron while crossing 2 points which are maintained at potential 1 volt. If 2 points A and B maintain at 1 volt, okay, and if electron cross these 2 points, then kinetic energy of the electron is called as 1 electron volt. So remember one thing here, conversion. 1 electron volt is equal to 1.6 into 10 raised to minus 19 joule. Okay. Instead of electron volt, if it is milli electron volt, 1 milli electron volt is equal to how much? 1.6 into 10 raised to minus 22. You know that this milli means 10 raised to minus 3. So minus 19 minus 3 minus 22, you can see. Now what is concept of potential? Just we have to learn this concept of potential. We already learned potential energy of two particle system, 1 upon 4 pi epsilon 0 q1 q2 by r. This is the potential energy for two particle system which are separated by a distance r, and potential energy is given by this. Now same formula we can write like this. We have taken q2 outside, or the same formula we can write by taking q1 outside. Okay, same formula by taking q1 outside. Now here this quantity q1 upon 4 pi epsilon 0 r is the potential, is the electric potential. So let me represent it by V, or V in a bracket R. And this quantity depends on charge Q and location. We already learned it is independent on the path. So same equation you can write, this equation you can write, this is potential V1 R into Q2, because it's a charge Q1. Similar manner we can write it V2 R Q1, and you can see they are equal. Here we are written same formula in different way only. Okay. So this electrostatic potential energy, we can write in this format also. U is equal to potential into charge. You can see here, you already seen, this is a potential and this is a charge. Okay. So we are written formula, electrostatic potential energy is equal to potential V into charge Q. V into Q, this is the formula. So electrostatic potential we can write. So this is the formula. You can see here, this is the formula for electrostatic potential. Okay. Electrostatic potential is electrostatic potential energy per unit charge. If you see this formula and this formula, okay, so only one charge is missing here. So electrostatic potential energy per unit charge, if we divide this potential energy by charge, we get electrostatic potential. So we get this formula. Just in the beginning, I told you electrostatic potential is, I told you electrostatic potential is work done to bring a charge. And that work done is nothing but the electrostatic potential energy. So electrostatic potential difference between 2 points is, so you can write the potential difference by this formula. So this is the potential difference. So difference in the two potential. So difference in the two potential energy divided by charge. So we can write potential difference is given by this formula. Electrostatic potential difference. In that formula, V2 minus V1 is the work done per unit charge to move charge from point 2 to point 1. So listen. Next one is relation between electric field and electric potential. Relation between electric field and electric potential. Electric field means electric field intensity E, and electric potential means electric potential V. Relation between E and V that we have to find. So we consider the electric field produced by charge plus Q kept at point O. We consider electric field produced by charge plus Q kept at point O. Now we consider diagram. So this is the point O. At that point O, we have to place a plus Q charge. And this is the direction of electric intensity. Electric intensity is directed away from this positive charge. This electric intensity is directed away from positive charge. Now, एक minute. Now we consider point M and N, which are separated by distance dx. The distance between M and N is dx, and this charge is plus Q. At point M, we consider a charge Q0 is placed. Q0 is what? Unit positive charge. What is unit positive charge? Unit positive charge means whose value is 1 coulomb. Okay? And this is direction of electrostatic force acting on this charge. Electrostatic force acting on this charge is, this is the direction. Now, the work done to move unit positive charge Q0 from point M to N means we have to displace this charge from point M to point N with a small distance against the electrostatic force or against the direction of electric intensity, and that work done is given by formula minus F into dx. Again, minus sign indicate that F and dx, they are oppositely directed. You can see here, this is electrostatic force, and we are displacing the charge in opposite direction. Now, this F is equal to Q0 into E. So how we get this? You know, electric intensity. Electric intensity is force acting on unit positive charge. So we can write F is equal to Q0E. This is the formula. So by this formula, we get work done is equal to minus Q0 E into dx. So we shift this Q0 to left hand side. So dW by Q0 is equal to minus E into dx. These are the mathematical steps. I hope you understand. But dW by Q0, dW by Q0 is potential difference. Potential difference between these 2 points. In the previous article, we already learned potential difference. Okay? Now we substitute. Hence, dV is equal to minus E into dx. Now we transfer dx to this side. dV by dx is minus E. Now we can write formula of E. And this is the relation. This is a relation between electric field and electric potential. So these are the easy steps that you have to remember. And this, you remember, this dV by dx is called as potential gradient. So this dV by dx is called as potential gradient. So we can write here E is equal to minus potential gradient. Thus, the electric field at a point in electric field is negative of potential gradient at that point.